In this video, let us go through the basics of the Python programming language. Python is a high-level programming language known for its simplicity and readability. As the most popular programming language today, Python is widely used in various applications, including web development, data analytics, artificial intelligence, and scientific computing. Here, I have a simple Python program to see if a user is eligible to vote or not. I use the print function to display "Enter your name" on the screen. The input function collects user input from the keyboard into the variable name. I then collect the user's age, make sure it is an integer by adding int, and using a pair of parentheses to surround the input function. If the age is larger than or equal to 18, followed by a colon sign and a new line with the print function, the script prints out the name of the user followed by is eligible to vote. If the age is smaller than 18, the script prints out the username followed by is not eligible to vote. As an example, I typed the same piece of code into a file named vote.py. I execute python 3 vote.py. Then it's going to ask me what is my name. I responded John and 20 years old. Then John is eligible to vote. If I type again and say the name is Paul, 17 years old, then it prints Paul is not eligible to vote. Python scripts can be run at the command line or as a script by using Python or Python 3 at the command line, followed by the file name of a Python script ending in .py. In this video, I am using both the terminal and Emacs and org mode to evaluate Python commands. In this .org file, opened in the Emacs software, I can put Python codes in this code block and directly output the executed results within the .org file. Similar way of Python code execution can be realized in a Jupyter notebook. Interested students can go to this website jupyter.org, click Try it in your browser, Jupyter Notebook, read the tutorial, and add commands at the end. For example, here I can execute in the notebook print hello world, and the results directly appear in line. You can also type these individual commands in a Python environment at the terminal and see the results there. Python interprets line by line. If you break the previous hello world print command into 2 lines, Python is going to throw a syntax error. If you really need to use 2 lines to execute the print command, you can add backslash at the end of the first line. Then Python will interpret these 2 lines correctly as one command. Different lines are interpreted differently when there are indentations. Here, there are 3 print commands. The first 2 print commands are indented and follow an if condition after a colon. They form a code block and are executed as a unit. Because if 3 is less than 1 is false, this code block will not be executed. Only the last print command will successfully print out the text string I will be printed out. Although Python interprets line by line, it is possible to have multiple commands in one line. We can use semicolon to separate multiple statements in one line if the readability is not sacrificed. For example, here I have 2 print commands. I can execute them all together in one line and get both hello and world. I can also assign a variable a to be 7 and print it on the screen using just one line with a semicolon. Both single quotation and double quotation work in the print function. We can use single quotes within double quotes as well. What if I want to print "That's Bob's book"? We can use escape characters. A backslash followed by the single quote ensures correct formatting in here. We can use similar syntax to use backslash followed by double quotation to print a string of text with multiple double quotation signs. We can use \t to indicate a tab, \n to indicate a line break, 2 backslashes to print the backslash. So combining all these, I can write print "hello there" \n, \t, how are you, \n, I, single quote, am doing fine. This will print all 3 lines of texts, with the first line broken after the exclamation sign, the second line started with a tab, and in backslashes. That's how to use these escape characters. Let us now talk about string formatters. The percentage sign can be used to form a string to contain values of identifiers. For example, over here I have 2 identifiers x and y. X is 50 and y is assigned to be 2022. I can print "it rained %s days last year, 2 days more compared to %s. Then I use another percentage sign and then parentheses x and y to format them into the string. The final result is "it rained 50 days last year, 2 days more compared to 2022. That is the first method to format a string. We can also use, starting Python 3.5, f-strings to do the same in a simpler way. Here, I have x and y again. X is 50, y is 2021. I can say print, then f, followed by quotation of all the texts in the string. Then inside, I can directly quote x and y by adding braces surrounding them. The result is going to be formatted into "it rained 50 days last year, 3 days less compared to 2021. So that is the f string. Now let us take a look at the math operators. Double asterisk signs indicate the exponent. For example, 3 asterisk asterisk 2 gives you 9. 4 asterisk asterisk 2 gives you 16. The percentage sign is the modulus operator and calculates the remainder of a division. For example, 5 percentage sign 2 or 5 divided by 2 gives a remainder of 1. 7 modulus 5 gives 2. 2 slashes indicate the integer division and calculates the float quotient. For example, 7 double slashes 5 gives 1. 20 double slashes 8 gives 2. A single slash indicates regular division. The asterisk sign indicates multiplication. Subtraction and addition are similarly intuitive. Okay, now we have covered the basic syntax of Python. Now let us talk about flow control. We have seen integers, strings in Python. These data types have infinite numbers of possible values. The Boolean data type only has 2 values, true or false. If A and B are 3 and 5, respectively, then comparing whether they are equal or not only has 2 outcomes. To compare whether A and B are equal in Python, we use 2 equal signs. To compare whether A and B are not equal, we use an exclamation sign followed by an equal sign. More generally, there are 6 comparison operators: equal to, not equal to, less than, greater than, less than or equal to, and greater than or equal to. In the first example here, we see the use of the inequality operator to compare 2 strings. This expression will evaluate to true because the strings dog and cat are not equal. The second example compares an integer 100 with a string 100 using the equality operator. This expression will evaluate to false because even though the values are the same, their types are different. The third example uses the greater than operator to compare 2 numbers. This expression will evaluate to true because 100 is larger than 90. Boolean operators are used for comparing Boolean values in programming. And, or, not are commonly used Boolean operators. 4 less than 5 and 10 less than 11 evaluates to true. 4 less than 5 and 10 larger than 11 evaluates to false. 4 less than 5 or 10 larger than 11 evaluates to true. Not 4 less than 5 evaluates to be false. 2 plus 2 equal to 4 and not 2 plus 2 equal to 5 and dog not equal to cat evaluates to true. The if-else statements are used to make decisions based on different conditions. In this example code, we have a variable name with the value Paul and the variable age with the value 3000. We use an if statement to check if name is equal to Paul. If it is, we print the doom awaits. If name is not equal to Paul, we move on to the else if statement to check if age is less than 15. If it is, we print you are not ready for the doom yet. If neither of the above conditions is true, we execute the else block and print you are neither Paul nor ready for the doom. This is how if, else statements work in Python to handle multiple conditions in a program. A while loop in Python will continue to execute as long as its condition is true. Here, the first code block uses an if statement, which only runs once and doesn't loop. The second code block uses a while loop, which repeats the print statement until span is no longer less than 5. To break from a loop, we can use the keyword break. In the previous code snippet, we can add an additional condition to check if span is equal to 3. If this condition is met, we exit the loop using the break keyword, allowing the loop to terminate early before span reaches 5. A for loop can achieve the same task. Here, we write for span in a range from 0 to 5. Loop 5 times, each time printing hello world followed by the value of span. If the value of span is 3, the loop stops. The range function here is a powerful feature in Python to describe a collection of data. It is useful for iterating over a sequence of numbers. Here I have a string Paul Atreides. I can use a for loop to index all characters in the string by writing for I in range length of s. Then I print each character and the index of the character. I can also easily reverse the index and print backwards using the reversed function on top of the range function. When you write range x, the output range starts at 0 and stops at x, not including x. Namely, range x generates numbers from 0 to x minus 1. For example, range 6 is from 0 to 5. The total length of the generated output is 6. You can use range to create other data collections. For example, a list ranging from 0 to 9 and the tuple from 0 to 9 can be created this way. The syntax for range in the full 3-parameter form is range, start value, stop value, and step size. For example, a list of range 0, 10, 2 gives numbers 0, 2, 4, 6, and 8. A list of range 10, 5, negative 2 gives numbers starting at 10, stopping at 5, with a step size of 2, namely 10, 8, 6. Let us now put the while and for loops in practice. A very common need in programming is to collect user inputs. Suppose we want to write a spice trading function, where the input is the weight of spice from the user, and the output is the value of the spice, which equals weight times the unit price. A simple code snippet to do this is as follows. We define the price per gram as 1 million per gram, use an input function to collect the weight of the spice, and print the total value that equals weight times price per gram. We can wrap these into a function called spice value by using def to define a function followed by the name of the function, a colon, and an indented code block. Then we can run the spice value function many times. Here, I have written the code snippet into the file spice0.py. In the command line, after we execute this spice0.py file, we can enter 10 and get the result 10 million. However, there are a few potential complications. First, the input function accepts both numbers and strings. In fact, the function accepts all the data types in Python. But we only want to collect the weight of the spice and want to reject other inputs that are not numbers. Here, if I run in the command line and enter hello, I get a value error. Second, even if the entered weight is a number, it may have been entered as negative. We want a positive weight. To address these complications, we can use a while loop with some if and else conditions. We add a while true loop, which always runs and will check if the entered weight is a digit or not using the isDigit function. If it is a digit, we use another if-else condition to check if the value is positive or not. Only if the entered weight is a positive number will the loop break. Otherwise, if it is a negative number, we print out amount must be greater than 0. If it is not an integer number, we print out please enter an integer number and repeat the loop. I have put these in a Python script named spice.py. Now, if I run python spice.py, if I enter 1.2, I am reminded to enter an integer number. If I enter hello, I am reminded to enter an integer number again. If I enter 2, the script now tells me the value is 2 million. Okay, now we have covered the basic syntax, simple functions, variables and data types, and flow control in Python. Let us now put these together to code a simple game. In the FizzBuzz game, players take turns counting up from 1. If a number is divisible by 3, then they say fizz instead of the number. If it is divisible by 5, then they say buzz. If it is divisible by both 3 and 5, they say fizz buzz. Let us code this in Python. We first collect from user the largest number to count to. For that, we use a while loop. While true, we first use input to ask the user to enter a number. If the number is a digit, we enforce it to be an integer data type and check if n is positive or not. If it is positive, we break from the loop. If not, we remind that the number must be positive. If the inputted content is not a number, we print please enter an integer number. Okay, now we have an integer number from the user. We use a for loop and the range function for I in range from 1 to n plus 1. Remember, when we use n plus 1 here, the generated number will be from 1 to n, which is what we want. To check if I is divisible by 3 and 5, we write if I %3 double equal sign 0 and I %5 double equal sign 0. If this is true, we print fizz buzz. If not, we check if I is divisible by 3 only. So elif I %3 double equal sign 0 colon and print fizz. Otherwise, we check if I is divisible by 5 only and print buzz. If none of these are true, then I is divisible by neither 5 nor 3. In that case, we print the number. So else colon print I. We can run this script with Python FizzBuzzPy. You see, we are asked to enter a number. Let us input 10. The results are 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz. Let us run again and count to 20. The results are 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz, 11, fizz, 13, 14, fizz, buzz, 16, 17, fizz, 19, buzz. Exactly what we wanted.